Most of the engineers don't hate end-to-end tests because they are slow or flaky. They hate them because they are expensive to write and rarely feel worth the effort. In this video, I will explain what makes that cost worth paying. Hello, my name is Matúš. I'm senior test automation engineer with over 8 years of experience, and on this channel I explain how test automation and software quality actually works in real systems. End-to-end tests are meant to verify critical business workflows, the things that actually matters to the system. That alone makes them expensive to write, because you are dealing with a lot of moving parts, simulating real users' interactions, and often integrating with third-party systems. If the end-to-end tests are expensive, they should give us more, just a fail or pass. They should describe what the system does on a business level. And that's where domain-specific language, or DSL, comes in. In the context of end-to-end tests, a DSL is a way how to describe system using business concepts without exposing implementation details. By the way, if end-to-end tests are new to you, I cover basics in my testing pyramid video. I will link it in the description. Once you have a DSL, a few important things start to change. The first thing that changes is that your tests become decoupled from the system implementation. Without DSL, your tests often interact directly with UI elements, locators, or API details. It might look something like this. You are clicking buttons, checking specific locators, or verifying implementation details. With a DSL, the same tests reads very differently. Now it looks more like description of system behavior, placing an order, confirming payment, or verifying the order status. Now imagine that the UI changes. The layout is different, the locators changed, or the whole UI was redesigned. If your tests are written at the business level, implementation of the test itself doesn't change. Only the implementation of the underlying business actions needs to be updated. So the intent of the tests remain the same, even the implementation evolves. The second benefit is that your end-to-end tests become a live documentation of the system behavior. Not documentation that gets stale on a Confluence, but documentation that remains honest because it executes. If the system changes in a way it breaks the behavior, the tests fail. That forces you either to fix the system or to update the tests, and therefore the documentation stays aligned with reality. And once the tests are written in this business form, it becomes easier to reason about coverage. You can look at the suite and quickly answer what workflows are covered, what features are covered, and what behavior do we really guarantee. In other words, you are not just automating the checks, you are capturing the system contracts in readable form. And that readability doesn't help only when everything is green. It helps even more when something fails. Without the DSL, failing end-to-end tests usually tell you what technical step actually failed. A selector wasn't found, a request timeout, or an assertion deep in the test didn't match. You still need to reconstruct what behavior the test wanted to verify. With the DSL, failing tests tell you what behavior is not longer true. For example, an order should be marked as a paid after successful payment, but it isn't. You immediately know what promise of the system was broken without debugging of the technical steps. And that changes the debugging completely. You are no longer searching through API calls and clicks to find the context. The context is already there in the language of test. The failures become signals about the system behavior, not noise about the implementation details. And that's usually when end-to-end tests stop feeling expensive and start feeling useful. It's also important to be honest about the trade-offs. A DSL is not something that you get for free. There is an upfront cost because you need to design it, implement it, and keep it aligned with the system when it evolves. If your system is small, short-lived, or changes rapidly, that cost might not be worth paying. And if you build DSL too early or at the wrong level, you can end up with an abstraction that adds more complexity instead of removing it. So the DSL makes sense when you have long-lived system, critical business workflows, and end-to-end tests that you really rely on. Otherwise, it's often better to keep things simple. So the end-to-end tests feel expensive for the reason they operate at the most costly level of the system. And the DSL doesn't make that cost disappear. It makes sure you get something valuable in return. When end-to-end tests describe system behavior, stay decoupled from implementation, and give clear signal when they fail, they stop feeling like a burden and start to feel like an asset. And that's when writing them become worth the effort. If you are dealing with problems like this, that's what this channel is about. If you see differently, I would be interested to hear your perspective in the comments. Thanks for watching.